You type a prompt into a chatbot, explain quantum entanglement, hit enter, and words start streaming back. But what actually happens in that instant? We're going to follow one single word, explain, on its complete journey, all the way through the network, watching every piece of math from the last 5 videos fire in sequence. That whole journey, from a word going in to the next word coming out, is called one forward pass. This is the capstone. Everything, vectors, matrices, softmax, attention, positional encoding, finally working together in one place. Here's the shape of it. One forward pass takes a word in and produces the next word out, and it always runs through the same 7 fixed stages in order. Embed, add position, attention, feed forward, output, softmax, sample, 7 steps. And every one is a video you've already watched. Then the model runs all 7 again from the top for the word after that. 1 pass per word. Zoom all the way out first. A forward pass takes 1 word in and produces, not a word, but a number for every possible next word. The whole network, however deep, is a function, word in, a probability for every word out. Here, after seeing explain, the top guesses are quantum at 41%, the at 12%, how at 7%. So the output isn't a single word. It's a guess spread across the entire 50,000 word vocabulary. The model picks from that. Now let's open the box. Here's the plan. First, the 7 stages of a forward pass, and each one is a video you've already watched, just slotted into order. Second, the loop, why this whole pass runs again for every single word the model writes. Third, the trace along will push explain all the way to quantum, end to end. And a bonus after the cheat sheet, the KV cache, the trick that makes each new word cheaper to generate than the one before. This is the episode where vectors, matrices, softmax, attention, and positional encoding all finally meet. Here's your whole map, the 7 stages of a forward pass, each tagged with the video that taught it. Embedding, position, attention, feed forward, output, softmax, sample. 2 of them, stages 3 and 4, attention and feed forward, form one block that's repeated about 80 times over. And the forward pass itself? Here's the key idea. It's all 7 stages run once, turning one word into the next. Then it loops, all 7 again, for the word after that. Now let's walk each stage and meet the old friends. Stage 1. The word explain is first turned into a vector by a simple table lookup. It's embedding. Out comes a learned vector. Here, just 4 numbers, but about 1,500 in a real model. Straight from the vector's video, a word becomes a point in meaning space. That's the entry door to the whole network. Stage 2, we add the positional encoding, the sign encoding stamp, so the network knows explain is the first word, not the 5th. Embedding plus position, added dimension by dimension, gives one combined vector that carries both meaning and place. That's the positional encoding video doing its one job right here at the front of the line. Stage 3, the centerpiece, attention. Our explain vector looks at every other word and asks how relevant each one is. Quick, predict which 2 it will focus on. First, it scores them with query.key straight from the attention video. Quantum scores 1.8, entanglement 1.1, the rest near 0. Then softmax turns those scores into weights, 0.6, 0.3, 0.1, and they sum to 1. There's your number to check by hand, softmax of 1.8, 1.1, and 0 really is 60, 30, 10%. Now blend the word's value vectors by those weights. Mostly quantum, some entanglement, and explain comes out context-aware. That's the entire attention video, compressed into a single stage, query.key, softmax, weighted sum of values. Stage 4, the feed-forward network. The context-aware vector gets pushed through 2 large weight matrices, expanded, then projected back down. Each token, on its own, reshaped by those matrices, and these are the biggest matrices in the model. This is the matrices video, where most of the parameters and most of the compute actually live. Attention mixes words together. The feed-forward then thinks hard about each one individually. Now the crucial structural fact. Attention and feed-forward together form one block. And the model doesn't run that block once, it stacks it. Layer 1 feeds layer 2, feeds layer 3, about 80 times over in a large model. Our explain vector gets refined a little more at every single layer. No shortcuts, no early exit. The token rides the full stack, top to bottom, every time. By the end, it's a deeply contextual representation. Stage 5. After 80 layers, the final explain vector hits one last matrix, the output, or unembedding layer. It produces a raw score for every word in the vocabulary, 50,000 numbers. These are the logits from the Softmax video, raw, unbounded, and not yet probabilities. One vector in, 50,000 scores out, the model's gut feeling about every possible next word. Stage 6, Softmax. It takes those 50,000 raw logits and squashes them into clean probabilities that sum to 1. Quantum 41%, mechanics 18, the 12, and so on down the list. That's the Softmax video, and if you nudged the temperature, this is exactly where it would sharpen or flatten the distribution before the pick. Stage 7, the finish line, sample. We roll a weighted die over the distribution, and quantum comes out, the model's first output token after explain. Usually it's the top word, but not always. That little bit of randomness is where the model's voice and variety come from. One word in, one word out. A full pass complete. Here's the loop that turns one word into a whole answer. We had explain go in and quantum come out. Now append quantum to the prompt and run the entire pass again, all 80 layers, and out comes entanglement. Append that, run it all again, and get is, again and again. Every single word a model writes is one complete forward pass through the whole network. The answer is built one token at a time, left to right. Time to bust the biggest misconception about how this all works. The myth. The model thinks up the whole answer, then types it out. The reality, it only ever predicts the very next token. When it writes the word the, it genuinely does not yet know what comes after it. The plan you sense in a good answer is an illusion. Coherence emerges from predicting one solid next word, over and over, each pass conditioned on everything written so far. Quick one for the comments. And actually, guess before the hint. A 200-word answer takes roughly how many complete forward passes through the network? Take a real guess. About 1 per token. So a few hundred trips through all 80 layers, just for one reply. Drop your number and your jaw in the comments. Let's run the whole thing in one breath. Explain all the way to quantum. 1. Embed explain into a vector, the vector's video. 2. Add its position, meaning in place fused, the positional encoding video. 3. Attention blends in quantum and entanglement, the attention video. 4. The feed-forward network reshapes it with 2 big matrices, the matrices video, and that block runs 80 times. 5. The output layer fires out 50,000 logits. 6. Softmax turns them into probabilities, we sample, and quantum comes out, the Softmax video. 5 videos, 1 unbroken chain, and the model immediately runs the whole thing again for the next word. That's a forward pass. Let's count the matrices our one token actually touched. It starts at the embedding matrix, then in attention, 4 matrices per layer, WQ, WKey, WV, and the output projection, WO. Then the 2 feed-forward matrices, W1 and W2. And finally, the output matrix at the very end. That's 6 big matrices in every layer, 4 for attention, 2 for the feed-forward, times about 80 layers, plus the embedding and output matrices at the 2 ends. And every single number in all of them was learned during training. So a forward pass is really just your data flowing through a giant stack of frozen trained matrices. No magic, just multiplication, in a very particular order. Pause and screenshot the whole model on one screen. The 7 stages: embed, add, position, attention, feed, forward, output, Softmax, sample, with stages 3 and 4 repeating about 80 times. All 7 together are one forward pass. A forward pass is one word in, a probability for every word out. Every stage is a video you've watched. Vectors, position, attention, matrices, Softmax. The model writes one token per pass, then loops for the next. And the big idea to keep, what looks like thinking, is data flowing through frozen, trained matrices in a fixed order. Bonus round, unlocked. If every new word reruns the entire sentence through 80 layers, That sounds horribly wasteful. It would be, so models cheat cleverly. Here's the insight. Attention needs the keys and values of every earlier word, but those keys and values don't change once a word is written. So the model computes each word's K and V exactly once and stores them. That store is called the KV cache. Each new token then only computes its own query, key, and value and reuses everything cached. Far less work per step. It's exactly why the first token of a reply feels slow, filling the cache, and then the rest stream out fast. Same forward pass, you just never recompute what you already know. Let's lock it in. 1. A single pipeline explains the entire model: embed, add position, attention, feed-forward matrices, softmax sample. 2. It runs one token at a time. Every word is a full pass, and the answer is built left to right, each step seeing everything before it. 3. It's all learned matrices. No handwritten rules, no logic branches, just trained numbers, multiplied in a fixed order. Vectors, matrices, softmax, attention, positional encoding. You have now seen the whole machine, end to end. You can genuinely read a forward pass, which leaves one last question. If this is one brain, why do bigger brains get reliably smarter, and by how much? That's the finale, scaling laws. This is video 6 of 7. Drop your forward pass guess in the comments, and I'll see you for the last one.